Hello everyone, in this video I'll show you how to convert binary number to decimal number. Here I have a binary number and I need to convert it to decimal number. As you can see, this binary number does not have any binary point or fractional part, which means that this binary number is an integer type binary number. For any integer type binary number, the positioning starts from 0 and moves on from right to left, which means the position of this particular bit is 0, of this bit is 1, 2, 3, 4 and 5. Now I have written this binary number again over here. Now I have to write the positions of each and every bit of this binary number. As I already said that the positioning starts from 0 and moves on from right to left for any integer type binary number. Therefore, the position of this bit is 0, of this bit is 1, 2, 3, 4 and 5. Now, each and every bit of a binary number carries certain position weight, and that is given by 2 to the power n. Right? Now, I'm going to write the position weights beneath it. So, firstly, I'll write all the 2's and then n. So, 2, 2, 2, 2, 2, 2. Now, n. So 5, 4, 3, 2, 1 and 0. Right? Now, for converting this binary number to decimal number, we simply need to multiply this bit with this position weight, this bit with this position weight, this bit with this position weight and so on, and we need to add all of them up. Right? So let's do it. So I've written the binary number over here, and now I'm going to multiply this bit with its position weight. So 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1, 1 into 2 to the power 0. Okay. Now, this would be 0 and this would be 0. 2 to the power 5 is equal to 32. 2 to the power 4 is equal to 16. 2 to the power 2 is equal to 4. And 2 to the power 0 is equal to 1. 16 plus 4, 20. 1. 21 plus 32 is 53. So this 53 is the decimal equivalent of this binary number. Now, let's take a look at the second example. Here, I have a binary number and I need to convert it to decimal number. As you can see, this binary number has a binary point and a fractional part. In this type of binary numbers, the positioning is done in a different way. Before this binary point, the positioning starts from 0 and goes on increasing from right to left. And after this binary point, the positioning starts from -1 and goes on decreasing from left to right. which means the position of this bit is 0, of this bit is 1, of this bit is 2 and 3, and the position of this bit is -1, of this bit is -2, of this bit is -3, and of this bit is -4. Here I have written this binary number once again, and along with it the position of the bits. Now, in the previous example, I have told you about position weights. So, I'm going to write the position weight of each and every bit here. So, the position weight is given by 2 to the power n. So, firstly I'll write all the 2's and then n. 2, 2, 2, 2. Okay, now n. So 3, 2, 1, 0, -1, -2, -3, -4. Now, to convert binary number to decimal number, we need to multiply each and every bit with its corresponding position weight, and we need to add all the products up, right? So let's do it. So 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0 plus 1 into 2 to the power -1 plus 0 into 2 to the power -2 plus 1 into 2 to the power -3 plus 1 into 2 to the power -4. So now let's do the calculation. So this will be 0, this will be 0, and this will be 0. 2 to the power 3 is 8, 2 to the power 1, 2, 2 to the power -1 is 0.5, 2 to the power -3 is 0.125, and 2 to the power -4 is 0.0625. Now we need to add them up. So you can use a calculator. So it would be 10.6875. So this is the decimal equivalent of this binary number. I hope you have understood it. So thanks for watching the video. Bye bye.